So dear students, in this video we are going to study electrostatics of conductors, though it is before dielectric and polarization, which I have already started. But if I like when I saw the book, this part was before dielectric and polarization. So I wish to do this part today, and we'll continue dielectric and polarization in the later classes. So I've already noted a few points on the electrostatic of conductors, which is in your book. So you can copy these points from the book itself. And in this class, we are going to understand what these points really means. So first point under electrostatics of conductors is inside a conductor, electric field is zero. So if I have a conductor, so now under electrostatic condition, which tells us that under electrostatic condition, charges must be at rest. So electrostatic. So electro means charges, static means rest. So charges should be at rest under electrostatic condition. So if you have a non-zero electric field, let us take, if you have a non-zero electric field inside the conductor, then what will happen? Then the charges inside the conductor starts to flow. Charges inside the conductor starts to flow along the electric field. But that is observed. But that is not possible under electrostatic condition, because charges should be at rest under electrostatic condition. That's why this electric field must be zero inside the conductor, such that the charges inside the conductor shouldn't be or cannot be flow. Our next fact or next point is, at the surface of a charged conductor, electric field is normal to the surface. Now at the surface, the electric field is non-zero. So if you have charges on the surface, then the electric field must be normal to the surface at the surface. Because if there were electric field, some value of the electric field along the surface, then what will happen? Then the charges will flow along the electric field. And if this electric field is along the surface, so charges will flow along the surface, which is again absorbed, because charges shouldn't flow in electrostatics. So that's why electric field is always normal at the surface, because at the if electric field is normal, then charges cannot flow from conductor to the along the electric field, because along the electric field there is no medium at all. So if it is a medium here, then the charges cannot flow from conductor to air, because air being an insulator. That's why electric field is always normal at the surface, which is point number 2. Now the point number 3 is, the interior of a conductor can have no excess charge in the static situation. So it tells us that for a conductor, the interior of conductor can have no excess charge. That means the net charge inside the conductor must be 0. This is directly from the point 1. Why so? Because if you have a non-zero value of the charges inside the conductor, then what will happen? And if you consider a Gaussian surface enclosing this non-zero charge Q, then the value of the electric flux flowing out of this Gaussian surface, the value of the electric flux flowing out of the value of the electric flux flowing out of the surface will be equals to Q divided by epsilon 0. So if flux is Q divided by epsilon 0, then the electric field lines will come out of this Gaussian surface. And if electric field come out of this Gaussian surface, then the charges inside the conductor will flow along the electric field lines. So charges starts to flow. The charges inside the conductor starts to flow along this electric field lines. And if charges starts to flow along the electric field lines, this contradicts our electrostatic condition, which tells us that charges shouldn't flow. Now, now if charges cannot flow inside the conductor, then electric field must be zero inside the conductor. And if the electric field must be zero inside the conductor, the charge enclosed by any Gaussian surface should be zero. Then only we'll get the value of the flux to be zero. That's why at the interior of the conductor there shouldn't be any net charge. So that's why the net charge inside the conductor is always zero. So we can say that charges do not reside on the interior of the conductor, but charge resides on the surface of the conductor. So if you have a surface this way, so charge do not reside on the interior, but rather charge resides on the surface of the conductor this way. So charges resides on the surface of the conductor. So this is our point number 3. Now the point number 4 is electrostatic potential is constant throughout the volume of the conductor. So for this, I want to consider a spherical conductor of radius r. Now we know the charges shouldn't reside inside the conductor, but charges resides on the surface of the conductor. So if I have a spherical conductor with charges as its surface, then at surface the value of the potential will be equals to Q divided by 4 pi epsilon naught r. So this is the value of the potential at the surface. Now if you were to bring one unit positive charge from surface to any point on the P, any point inside the conductor where electric field is zero, where electric field must be zero inside